Do you guys remember this Prentice Bulldog vise? I knew the first time I held its hand, we'd have a lot of great times together. Then some idiot came along with the cheater bar and broke it. It's been tortured and abused. It's lived a hard life, but it's not dead yet. I think the vise deserves to be resurrected, so I have an idea to teach this old dog new tricks. I'm gonna start by removing all the broken bits and repair all the cracks in the castings. I'll be relocating the main nut by attaching a tail to the main vise body. I'll upgrade the screw with bearings and try to keep the original meatball and handle to try to keep it authentic looking as possible. After the vise has been assembled, we'll be retesting the vise for clamping force, and then hopefully we'll have turned a great vise into a super vise. The first step I want to do is remove the spindle out of here, so I'm going to torch it and I'm going to clean it, and then at some point in time I'm going to repair this crack in the top of the slide, so I think I'm going to start with that first. You can see the last repair in here, which is kind of cool. They put some screws on this side and then they stick welded. I can see where they blew through in a couple spots. Their stick weld actually worked. Here's what actually broke when we did the test of failure, is the flag on the nut snapped off. This is a dovetail and it slips inside the body of the vise, as you can see there. And then this dovetail, to keep it from coming back, is held in by this pin. It's really that easy. So now we got this all out, we're ready to clean it up, sandblast it, degrease it, and get ready to do some modifications to this. I'm gonna find out where the crack is with the torch, because when I heat it up, it's gonna want to expand. Somewhere right there. So now I'm gonna put a center punch there and then I'll drill it. Definitely gray cast iron, you can tell by the chips. They're really small pieces. If you're interested to learn more between gray, ductile iron, I have a video on how to identify that. Happy the way the braze bonded to the cast iron. It looks funny and they never look like a perfect bead, but it kind of fills in all the voids, and you can tell that this tail has some scratches in it, so that's kind of what they always look like. But it's got a good bond, I can see it. I want to strengthen this whole tail of this slide, and I'm going to do that by putting a piece in here and filling this back in. Got that piece of channel all blended in there, and it looks weird because the casting has all these weird imperfections, so when you grind it smooth, you know, that's a low spot in the casting, so when it fills in with bronze, it bleeds over there. But this should help strengthen and keep this from flexing. The next thing I want to do is build the tail holder, tail puller, nut holder. Man, all these things they just sound just like a country line dance. But that's the next project. Start getting close. going to be brazing this mild steel to this cast iron with this flux coated bronze. This is 1/8 inch diameter, and when you're working with a large casting you need lots of heat, so I'm going to be using the cutting torch. I was taught to use a cutting torch when I first started working at the steel mill with the old millwrights, and I've just kind of stuck with it ever since. You can use a large welding tip or even a rosebud if you have a really big piece of cast iron that you need heated up. When bonding mild steel to cast iron, I found that it allows a flexible joint or coupling between the two, so that's why I'm using the bronze in this application. We have success. We got the tail combined with the body. With the braze on here, I think it adds a cool little feature and detail. I got a couple little low spots I need to come back in and fill back up, but overall I think it looks pretty neat, getting this Frankenstein look happening here. But the next step I want to tackle is adding the screw to the spindle, or at least making this screw. If you look at the original spindle from Prentice, they probably built it custom in the factory. It's like some 4 and something or other threads per inch, but I'm gonna make this readily off the shelf 5 threads per inch, 1 Acme thread. We could easily here build another whole spindle and make a meatball and a new handle, but I really like this old one. I think it has some style, it has a story to tell, so I'm gonna try to combine this meatball with this Acme and see if I can keep it strong. What I'm trying to do here is I want to have an interference fit between the meatball and the new Acme shaft. So I'm going to turn this shaft down by using the boring bar, and I'm going to turn the boring bar reverse and cut around the outside and go in. This was just too hard to kind of get chucked up in the lathe right. You got 2 different diameters. It was just kind of awkward. I think this is going to be the most controlled and the most safest way possible instead of this shaft flinging all over the place in the lathe. So we're just going to turn this diameter down just a little bit, and we'll make a mate on the Acme thread. We got the meatball welded to the Acme thread here. I'm ready to put some bearings on here to give this vise a really smooth action and hopefully increase the clamping force with less effort. I want to use the same bearing that I used on the red vise, and this is a ball bearing, thrust bearing. So its loads are designed to be sandwiched, that pressure, and I want to put it on the back side of this vise right here. But in order for this really to work, I need to make a pocket for the outer race to kind of sit in. And what this is also going to do is it's going to prevent what I call the spindle rub. So the original design was that it just slipped inside here like this, and then when you were to torque, not only are you putting pressure on the face, but on the side of the hole. So you're actually kind of rubbing on the side of the shaft and on the back face, which just increases friction, and over time that hole gets wallered out and enlarged. So by putting this bearing in there with the pocket, this is going to keep the spindle concentric to the hole, reducing friction. So when you do that, we'll take that to the milling machine. And then on the back side, because like I said, we want to be able to have some, when we release the pressure, it's smooth also. We're going to put this real thin thrust washers, thrust bearings on the inside. And this is the nut that goes over the top, and this is what pushes it backwards. And that will go inside of this little pocket inside here. So we need to take it to the milling machine first, carve ourselves a hole, and then we'll assemble it all. bearing. The K&T did an awesome job carving out that pocket in the front of this dynamic jaw for the bearing to sit in. We got a couple little chips out of the edge of it because that casting was so thin, but it's still going to do its purpose of keeping that bearing concentric with the bore of the slide. So since we did away with that nut that was in the middle of the body, we need to add the nut back into here again. So I'm going to extend the nut from the back of this tube to the middle where this one previously existed, and then we're going to add in some nuts and weld them to this extension. So let's build this extension tube and all the parts to fit to the tail. I need 2 pieces of plate, one that fits on the inside of the tube, one that's on the outside, and they will be bolted together, and then we will be able to weld this 1.5" nut to one of the plates. So let's get these cut and welded. Got our nut extension all fabbed up and located and welded onto the plate. And as you can see, we have the bracket in the back that this plate bolts to, and then clearance in here for the tube to slide through. Since this is removable, unlike the red Fireball vise, I can experiment with different thread pitches and just make this piece and a new screw and keep the body and everything and do some experimenting with it. This is the nut that when you retract the screw is what pulls on the back of the dynamic jaw. And I want to make another one of these because there's 3 individual little washers here, and they kind of like drop down into the grooves of the Acme thread. So I'm going to make a new nut out of this piece of material, and I'm going to make a little pocket for these washers to sit in, except for the very last washer. I'm going to leave it kind of proud so that it can make contact with the back of the jaw, and that will keep these washers all together and in line and concentric with the shaft. So let's make a new nut. Got our return nut finished. I have 2 3/8 locking screws that'll lock it down to the shaft. This is a lot beefier than the original, so should see a lot of good life out of this. And the purchase on the shaft is quite a bit bigger too, to keep it from wanting to twist or rock. And the screws are kind of not in line with each other. That should help it too. Let's get the spindle and the sleeves and the bearings all installed, and let's get this vise together. Man guys, we got the vise all together. I heated up the vise to get the pores all opened up, and I put some linseed oil in here to try to soak some oil in. I really want to leave it just like it is. I love the battle wounds, the scars, the wrinkles of its age. This thing's probably 80 years old easily. I want to leave the original patch job that someone did to repair the vise. And then of course, this little Frankenstein tail that we added on and bonded with the brazing. It's new, old, rusty, new, oily look. I just kind of like it. I just dig it. It tells a story. I love how the bearing kind of retrofits right into the casting. It almost looks like it belongs there. Having the tail dragger or the tail puller, the tube extension. I don't know, we got to come up with a better name for this style type of vise where we pull off the back. But I want to show you something, how smooth this vise opens up now with the bearings in the front and the back of this jaw. Watch this. Look how much just the vise handle swings back and forth. I mean, look how close my finger is to the meatball. It is almost too smooth. This will almost come back and hit you in the teeth if you're not careful. So I'm thinking I'm ready to actually see what the clamping force is and if we can at least match to what it was originally with that flag style nut inside. I'm curious. Let's go do it right now. What was our previous test? Flashback? As tight as I can get it. We peaked at 11,195. Well, there it goes. 15,987 pounds. Here we go. What are we up to? 5,000, 9,000, 13,000, 15,000. There's 16,000 just with the handle. I know I could probably get another 4,000 pounds out of it. That's where the vise failed before. Here, let's loosen it up. This is how nice it is to loosen. Oh, look at that, one finger from 16,000 pounds. Huge improvement from before. I think these vise mods turned out great. We were able to strengthen the vise overall while increasing our normal everyday clamping pressure with less effort from the handle by adding those bearings. A lot of you have requested to test the big twin screw shaper vise that's on the 36-inch Cincinnati. This is a 50,000 pound probe, so we're not going to take it anything past that if it does want to exceed it. But we're going to use this big cheater bar and see what the pressure this big monster vise can produce. Well, this stuff. I'm hanging on that pretty good. That's what, close to 40,000 pounds. Oh, man, that's about all I can get. I'm gonna try this one a little bit more. Well, that's a lot of clamping force. Just changing a little bit. It's not pushing really square now. So there you have it, 42,000 pounds. You need the clamping force on this machine because the ram will literally push her part right out of the vise. So I'm glad to see that this vise can hold that much pressure. Well guys, this was super fun to be able to Frankenstein this vise and repair it and get it back into working condition and have a kind of a cool little piece of history. I'm going to be giving this vise to my dad. He's in need of a bench vise and he showed some interest in having this after I talked about repairing it. So it'll be passed on to him. I really like making these videos for you. So please subscribe if you aren't subscribed already, and I'll catch you on the next one.